Hello and welcome to Explore by the Hydrus. Today, you'll begin your training as a marine biologist. Before we dive in, let's test your tools. First, use the trigger button on the back of your controller to click on the girl touching hands with the diver. Great job! Now click on the diver to start your journey. Your job as a scientist is to observe carefully and report honestly. Let's see how carefully you can observe marine life, starting with manta rays. These are coral reef manta rays. They're about 14 feet from wingtip to wingtip. Look closely at the markings on this manta's belly. Then select the photo in this database that matches the one you're swimming with. Nice work! These belly markings are unique to each individual manta ray, like fingerprints. Scientists use photographs of manta rays to tag and monitor them. Try to identify this one. It's tricky because the manta is upside down doing somersaults to capture food. Great job! Their movement guides seawater into their mouth, and special filters called gill plates collect their food from the water. Oh wow, this one isn't in the database. That means you get to name them. Great name! Thank you for your contribution. This database helps us better understand these animals and make decisions to protect them. Corals are small animals with soft bodies that build habitats for other marine creatures, like fish, turtles, sharks, and manta rays. When they experience high temperatures, corals expel their zooxanthellae, a type of algae that gives the corals energy. Without them, corals turn clear so you can see their white skeletons. This is called bleaching. Your task is to use satellite data to identify 5 coral reef regions in our ocean that are at risk of bleaching because of high temperatures. Use this flashlight to highlight the areas at risk and gather information. When you scan a region, you'll save a 3D model of a local coral specimen. Sometimes scientists study coral reefs by exploring the ocean. Other times, scientists study it by using special technology, like satellites in outer space. Good job! By identifying and monitoring regions that experience coral bleaching, you've helped us understand how we can better protect them. Decreasing carbon emissions on individual, industrial, and international scales will reduce the rate of ocean warming and give coral reefs a chance to persevere under climate change. This scientist is using special underwater paper and a regular pencil to record everything she sees in that meter-by-meter square. By doing this over and over again, she can measure how unique, healthy, and diverse that reef is. Today, you're going to conduct surveys to measure biodiversity, which is the variety of life in a given place. Go ahead and carefully place this quadrat over the reef in front of you. This high-tech quadrat will help you count the number of species in this area. This number represents species richness and is one way to measure biodiversity. Based on our records, this reef is less biodiverse than it used to be. Let's go back a decade and see what it looked like. Wow, this reef really has changed over the years. The greater the biodiversity of an ecosystem, the stronger and healthier it is. Let's take a look at the new readings and see the difference. Great job, you've collected your data. Maybe you'll come back in a few months, or next year, to take new measurements. When scientists return to a study site over and over, they can understand and identify drivers of change. Congratulations on completing your marine biologist training. You tracked manta rays, observed ocean habitats from space, and measured coral reef biodiversity. Well done. Stay curious and keep exploring. The ocean needs you.